All right, we're going to do Chapter 2, Section 8, Literal Equations and Dimensional Analysis. So the first piece we're going to talk about is just the ability to kind of manipulate or move things around so that the equation is set up the way we want it to be set up. So solving for a specific variable is very important as far as getting, like I just said, the equation set up in the correct order. So we have a little less to do once we start plugging numbers in. So the same method you would use to solve the problem, although you'll have more than one variable at the end. So really we're just rearranging the pieces of the equation. And I can think of this as kind of a simple equation. If I have A equals B plus C, and I'm given A and I'm given B, well, I'd want to know what C equals, right? I can rearrange this very quickly. So before I start plugging numbers in, I can say, if I move this around, I can say A minus B equals B minus B cancels, even though I don't know what B is. Anything minus itself cancels out to 0. C. So now if I'm given A and B, I plug them in, and when I subtract, those equal C. It's a little quicker. This is a very simple one. We wouldn't necessarily have to rearrange this one in order to make it work, but sorry, you can hear my dog clacking in the background here, walking in the room. But this one is just kind of a simple idea. But we do have other ones where it's a little easier if we have it solved for that variable than trying to rearrange once we have the numbers in there. So it's really just, we're kind of manipulating it around, removing things to make it equal what we want it to equal in the first place. All right, dimensional analysis sounds, super fancy, but it's a process of carrying units throughout a computation. So there will be a unit at the end of the problem, and it gives meaning to the answer. So what that means is instead of just saying 8, I could say it's 8 inches, 8 feet, 8 cats, 8 dogs. I'm giving it some kind of unit. I'm just giving it meaning. It's not just a random number. It actually means something. All right. So let me scooch this down just a little bit so we can see the instructions up there. So the first two, we're really just going to go back and practice for a second, plugging in a variable. So for this one, actually no, this is directly a example of what we were just talking about. Sorry, I thought we were going to plug in a variable. I thought they were giving us what k equals, but no, this is actually exactly an example for this first piece where we're going to kind of manipulate it around. We're not going to have k equals or j equals, because if you notice, we have two variables here. What we're going to have at the end is, sorry, I said it funny. We will have k equals, but it's not going to be k equals a single number, is what I meant, or j equals a single number. It's going to be an equation that k equals. So they want us to solve for k. That means we need to get k all by itself. So just like we would normally do, we're going to start moving pieces away. Whenever the entire side is divided by a number, you want to get rid of that division first. Before you start doing addition and subtraction, I know that's normally what we go for first, but remember this means it's actually k divided by 5 minus 2 divided by 5. But since they're both being divided, we can just put it as one division symbol. So that's why instead of trying to deal with this minus 2, which is really minus 2/5, and I have to start adding and subtracting fractions, I can get rid of this whole division and move it to the other side here. So I'm going to multiply both sides by 5. And what that does is it's multiply by 5, divide by 5. That cancels down to 1. I know it should be up here, sorry, but I'm multiplying by 5. It's not division. K minus 2 comes down because that's all that's left, equals 11j times 5. So I do actually multiply the coefficients here, and I get 55j. And my last step to get k by itself is now just to deal with this plus 2. So I'm going to minus 2, and I'm going to add 2 to both sides. So I have k, the 2's cancel, equals 55j plus 2. Remember, you cannot combine these. One has multiplication happening, one does not. So order of operations says we can't combine them because they're not like terms. That's really what like terms is, a practice in order of operation. Which I know I've talked about that in previous videos, but that's all it is we can't add the 2 before we've done our multiplication. Okay, that's kind of the basic idea there. So this is the answer. This is what it's looking for. I have solved the equation for the indicated variable. K equals 55J plus 2. So now if we know what J is, we can just plug it in and quickly answer the question. And this is very helpful if we have to plug in more than one answer. So if we want to test it more than once, I can just plug in the first one they give me and give an answer pretty quickly. You know, the number you give me times 55 plus 2. And that'll tell me what K is in that situation. And then if you give me another number, I can very quickly plug it in. Instead of having to go through and solve it each time, where I have to, you know, divide and then multiply and then add, it's already set up for me to do this. So that's the reason, kind of going through and learning to do this, is that it does make it easier, especially when we have a situation where we're going to have to plug things in more than once. All right, we are now going to solve for Q. And Q is in here, it's in the parentheses. So since this whole thing is being multiplied by A, normally we'd want to go through and start distributing, right? That's what we would start doing for simplification. But because I want to get Q by itself and I don't want there to be an A with it, what I would rather do is instead, just like I got rid of this whole division, I can get rid of this multiplication. The entire side is being multiplied by A. So I can divide by A on both sides. What that does is it cancels out, times multiply. I'm dividing by the same number. I end up with Q equals 8 because the A is canceled, and 23A on the right side there. So now all I have to do is add 8 to both sides. And I have Q equals, the 8's cancel, and I have 23A plus 8. So this is the answer. This is what we're looking for here. So again, I know this can be a little confusing. I have students that they get to the end and go, wait, that's really the answer? We're not really looking for what Q is? Not necessarily. We don't know what A is. When we have two variables, we need to know one or the other in order to kind of start solving this. So we could actually start plugging, you know, numbers into this to figure out if A is 1, what would Q be, and things like that. But that's the idea, is we're just solving for the variable they tell us to solve for. So geometry, we're going to do a word problem here. The formula for the volume of a rectangular prism is V equals length times width times height. So that's what this stands for, is LWH is length times width times height. And a rectangular prism is literally, see if I can draw it here, boop, 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 a box, right? Oh, and this would be dotted because we can't see this. So something like that. I know that's not terribly perfect, but we can kind of get the idea there. That's a box. So it's a rectangular prism. So we have length, we have width, and we have height. So that's the idea of calculating volume. Solve the formula for W. So first, we want to take this formula, and we want it to be W equals instead of V equals. So we're going to start rearranging these pieces to get W by itself. It's pretty easy because it's all multiplication. So I'm multiplying by L, I'm multiplying by H. I can actually do this in one step. I can divide by the L, and it's a cursive L, sorry, and then H. I can actually divide by both at the same time. So I can take both of them away. They both cancel out, and I'm left with V divided by length times height equals our width. So it's not a terribly hard one to manipulate there around, and it doesn't matter that it has equal W. W equals would be the same idea. It doesn't matter which side the equals is on. It's still exactly the same idea. So now it says find the width of a rectangular prism that has a volume of 79 and 4/100 cubic centimeters, a length of 5 and 2/10 centimeters, and a height of 4 centimeters. So we're going to plug this in. So we have V equals length times height, and I'm going to put W on this side now just so it's out of my way. So volume is 79.4, and we have cubic centimeters like this. And cubic means that it's been cubed, so we have cube up here. Divided by, we have length times height, so it's length is 5.2 centimeters, and that's times 4 centimeters. And the reason I'm doing centimeters is to practice that idea of dimensional analysis that we were talking about, carrying units through, so we can actually see what we get at the end. And units actually kind of act just like anything else, like variables. We can cancel them out. So centimeters cubed, because it was cubic centimeters, means I have 3 centimeters. It means I multiplied centimeter times centimeter times centimeter to get here. So there's 3 of them here, and I have 2 on the bottom. So just like we would with a variable when we were learning how to do that with exponents and dividing the same base and exponents. So let me write it over here so that I'm not just saying it kind of funny. So when we were doing things like this with our powers, so this is our quotient powers, I can subtract. I can go 3 minus 2, and that's 1. So I just have x left over. X to the first power, but I don't need to put the first power. So I can subtract these exponents. Well, it's the exact same idea for the units, as long as they match up. So if I have 3 here, I can take 1, 2, and I'll have, if I take 2 away from 3, I have 1 left over. So I'm just going to cross this off and just leave that centimeter there, showing that I have centimeter left. So now all I have is this 1 on top. Really, these are gone, okay? All right, now I just have to deal with the numbers here. So 79.4 centimeters. Let's multiply these numbers on the bottom. So we have 5.2 times 4. And that one's not a horribly hard one to do in our heads, really. Because we could go 4 times 2, and that gets us 8. And then 4 times 5, and that gets us 20. And we do point. We just need to make sure we understand the rules there for when we're multiplying by decimal. Because when we're multiplying by decimal, we kind of ignore the decimal. We multiply like normal. We go 4 times 2, 5 times 4, and then it doesn't come straight down. It kind of looks like it is, but we only had 1 decimal place here, so we go 1 decimal place back. It looks like it's coming straight down, but it's really not. It's just kind of coincidental on this one. It comes straight down on addition or subtraction. But multiplication, we actually need to count those spaces. All right, so we have 20.8 on the bottom. I didn't bring the centimeters over because remember, those are gone. I crossed them off. I canceled them out. So now we need to do 79.04 divided by 20.8. And yes, we can use a calculator on this one. This would definitely require us to do some long division if we did it on paper. So if we did 79.04 divided by 20.8, remember, we don't want a decimal in front here. So we'd actually want to scooch this over. And we'd have to scooch this guy over too. So we'd end up with 208 and 790.4, or 4/10. And we'd bring this decimal straight up here. So that decimal does go straight up when we're doing division. Okay, so we could do this, but we can also just type it into our calculators. We could use this, and we would end up with 3.8 centimeters. So remember that centimeters comes over with it. And that is our width. All right, so that was section 8. Sorry, you get to hear my dogs in the background there. That was section 8, and I will see you in section 9.